Thanks, Kels. Now, why is dairy and cow's milk such a big part of a lot of Canadians' diet? Well, as we all know, cow's milk is an excellent source of calcium and vitamin D. Calcium and vitamin D play an essential role in building and maintaining good bone health. There are other vital components of cow's milk. It is a significant source of vitamin A, and it contains a balance of macronutrients such as protein in the form of casein and whey, carbohydrates, which are lactose and sucrose, and saturated and unsaturated fat. There are also different hormones present in cow's milk, such as insulin-like growth factor 1, bovine sex hormones, along with steroid hormones such as progesterone and estrogen. The media made reference to a study that highlighted specific components of milk as mediating agents in the dairy milk breast cancer link. These were bovine sex hormones and serum IGF-1 levels. Insulin-like growth factor 1 is a 70 amino acid linked polypeptide produced mainly by the mammary gland and liver. IGF-1 concentrations in milk have a wide range. This could be due to differences in body weight, milk composition, diet, management practices, and other environmental factors in the cows. IGF-1 levels were shown to increase in cows that are treated with bovine somatropin, also known as bovine sex hormones. Cows are treated with bovine sex hormones to increase milk production. Pasteurization of milk decreases IGF-1 but does not destroy it. The known bioavailability of milk IGF-1 in animals and humans is lacking. It is known to be structurally similar to insulin, which is degraded in the gut, but it is thought to have a higher absorption than insulin and less degradation. IGF-1 is related to insulin, and that it plays a central role in cellular glucose metabolism, amino acid uptake, glycogen synthesis, lipogenesis, and mitogenesis. The anabolic signals by IGF-1 can promote tumor development by an anti-apoptosis effect and also by stimulation cell proliferation. High levels of IGF-1 and insulin can both be associated with an increased risk of colon, pancreas, endometrium, prostate tumors, and breast cancer. Approximately 75% of dairy cows producing milk in modern dairy industry are pregnant and lactating. This results in estrogen and progesterone being present in their milk in increasing quantities depending on the fat content of the milk. Estrogen and progesterone stimulate breast growth, and estrogen is associated with increased mitotic activity and DNA replication errors, which can impact the development of breast and endocrine cancers, as can be seen in the diagram. Storage of these hormones is tied with fat, so this may be a factor in why some studies are showing a positive association of cancer with increasing milk fat content. However, different types of fat may contribute differently. Saturated fats have been associated with increased breast cancer risk. No significant association has been demonstrated from total monounsaturated or polyunsaturated fats. You may be wondering if the fat content in your milk is putting you at a higher risk for breast cancer. Well, if you consume low-fat dairy, the milk has been filtered to remove saturated fatty acids. Drinking low-fat milk has been shown to have both a decreased risk of breast cancer and also has no association with cancer development at all. While high-fat milk had a positive association with breast cancer risk, as it still contains saturated fatty acids, this could also be due to the fact that estrogen hormones reside primarily in fat, so the levels of estrogen may be substantially higher in whole versus skim milk. However, this evidence was given a grade of C. More research is needed to determine if the fat content is a significant risk factor for breast cancer. Now on to my colleague Tiana for some milk talk.